So cold differential test pressure, what is cold differential test pressure? Does anybody know what the cold differential test pressure is? Well, I'll explain it. CDTP, or cold differential test pressure, is the pressure that we set the valve on the test bench. So some of the influences on the valve are going to affect the valve while it's in operation, such as back pressure or temperature. So when it's in operation, that's a completely different scenario than when you're in your test facility or your maintenance facility and you're working on the valve. The temperature is going to be whatever the temperature is. 20 degrees Celsius, I think, is around normal. When you put it in operation, the temperature could be up to 300 degrees in this case. So your spring temperature is going to increase. That's actually going to lessen the amount of pressure that you have pushing down on your disc. So you want to compensate for that while you're setting the valve. So here it shows the set pressure is in operation. You want it to open up at 10 bar. And here down at the bottom, the CDTP says that if you want it to open up at 10 bar and the temperature in the plant or the temperature of the springs is going to be 200 degrees, then you need to set the valve actually at 10.5 bar to compensate for the spring compression loss. So this is all this information is very important, because when we size and select a valve for your operations, it's very important that we have all of the information that you guys are witnessing from your plant to help us understand your the scenario that the valve is going to go into. If not, then you could have a valve that you want open at 100 psi is not opening the way that it should. You've already seen these diagrams. The balanced bellows takes the compensation of the back pressure out of the situation, so you don't have to worry about that. So in this case, for the operation that the valve is going into in the plant, you're going to set it at 10 bar, which you have a constant back pressure of 2 bar. So if you put a conventional valve without a bellows on a test bench, you're going to actually set that valve at 8 bar to compensate for the back pressure. Does everybody understand that? Kind of show of hands. Does it make sense to you? That you're actually compensating for the back pressure in a conventional valve? Yes? It's very important that you guys understand, because these are safety devices and we don't want anybody to get hurt or your system to fail for some reason. So if you were to put a balanced bellows in the situation, you wouldn't have to compensate for the back pressure. You would set it at your test bench in your facility or your maintenance facility at 10 bar. You kind of see how that works? If you had a conventional valve without a bellows, you'd have to set the valve a little bit lower to compensate for all those forces pushing on the disc. And with a bellows, you don't have to worry about it.